What could be more spectacular than a space battle? In the movies, you see warriors over distant planets firing their weapons through space, spaceships exploding incredibly, bullets hitting their targets with ease, all surrounded by an unprecedented roar. Would these space battles be equally spectacular if they took place not on the TV screen, but in reality? In general, what happens if you shoot in space? Will a gun even fire? And what would happen to the bullet? And how will this affect the shooter? Riddle has conducted his own investigation and is ready to share the results. It's no secret that there's no oxygen in space. And besides the fact that it's an important component of the air we breathe, without it, the combustion process is impossible. Does it turn out that the gun won't fire? Well, not quite so. The composition of gunpowder includes its own oxidizing agent. This is a chemical substance that allows mixtures to burn even in airless space. It just so happens that atmospheric oxygen is not even needed. The smoke trail after the shot will look interesting. In space, it will form into a spherical shape at the end of the gun barrel. By the way, the sound of the shot will not be heard because the transmission of sound waves in a vacuum is impossible. And what will happen to the bullet itself? On Earth, a bullet fired horizontally tends to slow down due to air resistance and begins to fall to the ground due to gravity. A bullet fired from a rifle loses half its speed after about 500 meters, or roughly 1,640 feet. If we fire a gun on the moon, then due to the lack of air, the speed of the bullet won't decrease. According to some estimates, if you take a modest figure of 500 meters or 1,640 feet per second for the speed of a bullet fired vertically, then in the absence of an atmosphere, the bullet could rise up to 12.5 kilometers, that's 7.8 miles. On the moon, where gravity is 6 times less than the Earth's, the same bullet would be able to travel as far as 75 kilometers or 47 miles. Let's take a more powerful gun. What about a Kalashnikov rifle with a bullet speed of about 1 kilometer or 0.6 miles per second? Alas, this bullet is not destined to leave the limits of the celestial body, since it won't be able to overcome the first orbital velocity, which is 1.68 kilometers or 1 mile per second for the moon. But if you were to fire a powerful military cannon from the moon, for example from a T-90 tank, then the result will be an artificial moon satellite. The shell will continue to rotate around the moon along a given path. It'll be much more interesting when we shoot into the vacuum while flying through space. What do you think will happen to the bullet then? It will simply continue its journey through the vast expanses of space and will never come to a stop. The fact is that the universe is constantly expanding at a speed of 73 kilometers or 45 miles per second. The world has not yet invented weapons that can launch a projectile with such incredible acceleration. Therefore, you can shoot as much as you like in the Milky Way, but your bullet will fail to escape it. Only some kind of obstacle would stop the bullet. And what will happen to the shooter himself, who dared to shoot in outer space? Well, nobody canceled Newton's third law. The shooter will be pushed with the same force which propels the bullet. Under zero-gravity conditions, the daredevil will begin to move in the opposite direction from the bullet's travel. But this movement will be barely noticeable and will be only a few centimeters or a few inches per second. Nevertheless, it's better to check your safety cable beforehand so you'll be able to return to your spacecraft safe and sound. Yet another possibility is the most unpredictable and tragic outcome of a shootout in space. There's a chance of accidentally shooting yourself. This will happen if you are, for example, in the orbit of a planet. Then the bullet will fall under the influence of the gravity of this planet, and after passing around it, will return to the point from which it was released. If you find yourself back in the same place, then the bullet will inevitably hit you directly in the back. It would be much easier to perform the same action standing on the top of a mountain on the moon, according to the hypothesis of author and astronomer Matija Suk. It's enough to direct the bullet towards the horizon. It'll fly into the distance at a speed of about 1,600 meters or 5,250 feet per second and will soon give you an unpleasant reminder, again, plunging directly into your back. In general, before having a shootout on the moon, it would be best to learn the art of dodging bullets from Neo in the Matrix. There's still time. I would also not discount the problems that may arise with an automatic weapon. This is only in case you suddenly decide to release an entire magazine into space. So for example, on Earth, there's a thin layer of air between the moving parts of a weapon that facilitates gliding. There's no such layer in space. In addition, cooling is also a danger. It sounds rather strange, but precisely because of the peculiarities of cooling in space, overheating of the firearm can occur. And a gun warmed up to high temperatures will almost certainly have problems with the movement of its action. In a word, a good shot in space will be possible only if there's a special space weapon designed to work in a vacuum and in abnormal temperatures. By the way, there's evidence that there has already been the firing of a weapon in space. We're talking about a modified version of the military cannon R-23M Kartek, which was launched by the USSR into orbit and put into operation in 1974. It was equipped with a 23mm aircraft gun, originally developed under the guidance of Aaron Richter for arming the Tupolev Tu-22, and after that, adapted for use in space. The weapon released about 20 shells into space. All of them burned up in the atmosphere. Little is known about the test results, since as of today, this information is still strictly classified. Perhaps these are not the only tests of weapons in space, and someday the veil of secrecy will be lifted. There was a time when weapons aboard the ISS were the norm. No, they weren't lying hidden in case of an encounter with aliens, but for possible self-defense if an unexpected landing back on Earth occurred in a dangerous place. In 1965, due to a failure of automated systems, Soviet cosmonauts Alexei Leonov and Pavel Belyayev were forced to land the Voskhod spacecraft in the dense, snow-covered taiga, 1,000 kilometers, or about 620 miles from the planned landing site. Landing, the cosmonauts risked becoming prey for the local bears and wolves. But eventually everything ended well. After a few days, the space explorers were found and rescued. But after this incident, the development of a special multifunctional weapon for cosmonauts called the TP-82 began. One barrel fired birdshot, the second bullets, and the third had flares, and the removable butt could be used as a machete. From 1982 to 2006, cosmonauts always took the TP-82 into space, even on board the ISS. For a long time, not one flight into space was made without a gun on board. But according to some reports, since 2007, weapons are no longer part of the space survival kit due to the expiration of existing cartridges and the lack of production of new ones. Only the Chinese cosmonauts are officially armed today. Taikonauts fly with pistols. But this doesn't mean that someone isn't trying to invent a real space gun, one that could come in handy when meeting with unfriendly aliens. Great expectations have been placed on a directed energy weapon. Its uniqueness lies in the fact that it releases intensely concentrated rays of energy directly on the target. These are microwave weapons, ultrasonic weapons or USW, and particle beam weapons. But the most widespread technology in use today is the high-energy laser. It shoots a soundless beam of energy, invisible at certain frequencies, and capable of burning a target from a distance of hundreds of kilometers or miles away. Honestly, that sounds creepy. I wouldn't mind if the laser weapon being developed was used exclusively to combat space debris, and star battles simply took their place of honor in science fiction books and Hollywood films. And let these battles continue to look unrealistic with no defense against the criticism of scientists. You must admit, they're an exciting sight. So, which space battle do you remember the most? Share with us in the comments. And don't forget to like and subscribe to our channel.